Here we look at how the model store project has evolved into machine learning as a service or deep learning as a service platform. The initial project presentation is available here. If you haven't seen it, you can access that initial presentation along with some recent updates from the links to the right. Now let's look at why we need machine learning as a service or deep learning as a service. Usually there are multiple models even within a single project, and there will be multiple projects. If we classify models broadly as deep learning models and machine learning models, even within each of those categories, each model is different, expects different input types. It belongs to different projects. They may be trained and built with different optimization techniques. For example, the two deep learning models that have been added to the store, one of them has been trained on the CPU with early stopping parameters, and the other one has been trained on the GPU. Now that's the models. Now we have these samples or out of bag data that users want to pass through machine learning or deep learning models. The samples are also different from one another. Each sample has a different set of feature dimensions, and they can also belong to different projects. Now that's the case for the service. Imagine that a user somewhere has generated or created a sample for an existing machine learning or deep learning model, and the user wants to pass that sample through that model and get the result. It can also be the other way around. Imagine that the user has trained and created a new machine learning or deep learning model and wants to pass existing samples through that new model, and the user also wants to make that model available for others. That's where the service comes in. The model store as a service allows users to load samples and or models, pass the samples through the models and get the result. And this is done over REST APIs. The tech stack for the model store derives from the initial project. We have the deep learning TensorFlow frameworks, and also other tools that have been added, which include Jira. Everything has been moved into Jira Kanban board, and the application is deployed on Docker containers as a scalable web application, and it is built, the containers are built, tested and deployed over with Jenkins. Now the service looks like this. Initially we choose the sample. Here we have filtered the samples using a tag which denotes deep learning, and we choose a particular sample, and the filter gets, or the filter tag gets passed over to the next stage, and we are shown the deep learning models that satisfy that tag, and we select one that has been trained over the GPU, and the service passes that sample through the model and presents the user with the result. Now there are different models in the store, both machine learning and deep learning, trained with different parameters. And this is an example of a deep learning model in the store, and the set of out of bag data that have been added to the store. Now the model store has been tested with 250,000 plus prediction API requests over REST, and this is a snapshot of the distributed task queues executing each of those prediction requests and sending the result back to the user. Now let's quickly look at a demo. Here we have the model store. Let's filter deep learning samples. Let's take this one, and let's choose this particular deep learning model which has been trained with early stopping, And we can also have a look at the model using the link which presents us with the individual details of the model, and we click submit, and the service will pass that sample through that model using Celery task queues, and you get the result back from the service. So here we have the classification as benign for that particular model on the project. Now let's try a different one. Let's try a different sample, and let's use the one that has been trained over the GPU, and we submit it. And we are presented with the classification. Now the same can be done over REST APIs. For example, the 250,000 plus requests were load tested using the GNU parallel command for different combinations of the samples and the models in the store. And that's it for now. Thank you.